Hello, welcome to Short Circuits, and in this video I'm going to show you how to light up a LED on 1.5 volts. So this is a 1.5 volt battery, and if you connect it directly to this LED, positive to positive and negative to negative, you'll see that it doesn't glow because this LED requires a forward voltage of 2 volts in order to glow. So we need a circuit which will double the input voltage, or we need some circuit which will boost the current. So for that we can use passive components like capacitors and inductors. So first we will use these capacitors. We'll arrange this capacitor in series such that both the voltages will add up. So these two transistors are in series right now. This is the positive side and this is the negative. So first we will charge this capacitor and then we will charge this capacitor, and both will store 1.5 volts. So both the voltages will add up to 3 volts, and 3 volts will discharge through this LED. That is the working principle of this charge pump circuit. The circuit is called as a charge pump because we are pumping charge through this LED. So we will connect like this. The circuit is made, and now we will charge the capacitor to the left side. Let's call it C1, and then we will charge C2. And you will see a bright flash once the capacitor discharges through. So as you can see that as I'm switching the position, as I'm charging any one of the capacitors, the LED flashes. So I need some electronic circuit which will switch the position from right capacitor to left capacitor very quickly. So first I will charge this capacitor with the help of 2 transistors, then I will charge this capacitor, and I will do that very quickly with the help of oscillator. So oscillator will control the switching, and we will see a constant glowing LED at the output. So I've made that circuit. So this is the circuit, and these are the 4 transistors. These 2 transistors charge this capacitor, and these 2 transistors charge this capacitor, and this is a common 2 transistor oscillator which controls this charging. First it powers this 2 transistors to charge this capacitor, then it powers this capacitor, and it switches very fast such that there is a constant glow of LED at the output. And you will see that the circuit works. The LED is light up on 1.5 volts, and it's a success, and I'm happy with the output. But there is one more circuit which is far less complex than what I've made here, and this is called as a Joule thief. I took this circuit from Every Circuit. A guy with username called Tech Planet made this on Every Circuit 7 years ago. So if he's alive, hello Tech Planet, this is your circuit made on the breadboard, and it works. I want to tell you that it's actually working, and the LED glows at the output. So this circuit works when this is a relaxation oscillator, as he called it, Tech Planet, in the description. This is a relaxation oscillator with inductive load, and when very high frequency current is passed through this inductor, the reverse spike is of very high current, and that reverse spike is passed through this LED, and we see a bright glowing LED at the output. I'm going to show you how that spike looks like, the reverse spike of an inductor. So remove this 2 capacitors, and instead of this I will place one inductor like this instead of the capacitors. So this is positive and this is negative. You have to connect LED in reverse of the polarity of the battery. So whenever we connect it, nothing happens, but when you disconnect it, you see a bright flash. That's because when we connect inductor to this 1.5 volt battery, the energy stored in the inductor is a form of a magnetic field, and when we release the switch, release the wire, the magnetic field collapses and you see a bright spike which is in opposite direction, and that spike is visible with the help of this LED because that current is very high. And if we switch on very quickly, if we do fast switching, then we can get to light this LED at very high voltage. So just now I'm just rambling how this circuit works, but forgive me because I know I'm not explaining with my best efforts, but I hope you understand it. Thanks for watching. Like and subscribe to this channel, and if you want to know this circuit, I have given links in the description to my every circuit simulation app. Link is given in the description, so you can log on to the every circuit platform and you can see my circuit, these two circuits made, and you can also simulate them. You can also play with the different components, change the component value and see how it works.